We have a clown in a rodeo. It's running. Now, they don't identify these vectors. They don't give them names. So I'm just going to give them random names. We're going to say the first vector, vector A, 8.0 meters north. Okay? Vector B, he turns and runs at an angle of 35 degrees east of north for 3.5 meters. Vector B. Vector C, he runs for 5.0 meters east. What's the result of everything that he did? That is going to be the resultant vector. The resultant vector is just going to be A plus B plus C. Whenever you are working with vectors, you need to draw a diagram, a vector diagram. Notice, my vector diagram starts with an arrow to indicate the direction of the vector. It also has a label next to it to identify which vector we're talking about. That's vector A. Vector B is shorter than vector A because it's 3.5 meters, right? As opposed to vector A, which is 8 meters. Plus, we know this angle right here is east of north, and that's 35 degrees. Then we have vector C. Vector C is about 5 meters, so it's somewhere between the length of A and B, and we're looking for our resultant vector, which is going to be this guy right here. Now, our goal is to figure out that resultant vector. This is a vector diagram. There are those of you, when you work on this, that you are going to want to simply draw something that looks like this. You can be like, Mr. Palmer, I drew a picture. That, ladies and gentlemen, is a trapezoid. It's not a vector diagram. Notice, vector diagram, we have labels to identify. We have arrows identifying direction, okay? Please draw your vector diagrams. Now, we cannot use the Pythagorean Theorem or SOHCAHTOA on here right now. Do we have a triangle? No. A lot of people look at this and they're like, oh, but we like draw a line over here and then we'll have a triangle. Like you use sines and dot cosines. I can do this and that. Okay. I like to give you a process that will work in any example. So, who could tell me what we should do next? David.
We should split vector B into two parts.
Notice, vectors A and C are both either directly in the x or y direction, right? Vector B is neither directly in the x or the y direction, so the first thing we need to do is break vector B into its components. So we have vector B, looks like this. We can figure out vector B in the y direction and vector B in the x direction. Right? We have theta. So sine theta equals opposite over hypotenuse. Opposite of theta is B in the x direction divided by the hypotenuse, which is B. Therefore, we get that B in the x direction equals B times the sine of theta. So let's get some numbers here. B was 3.5 times the sine of our angle 35 degrees. B in the x direction, please. 0.007517. Is plenty. So we can do the same thing with cosine. Cosine of theta equals adjacent over hypotenuse. Adjacent is B in the y direction divided by the hypotenuse, which is B. Therefore, B in the y direction equals B times a cosine of 35 degrees. Therefore, B in the y direction equals 12 times a cosine, 3.5 times a cosine of 35 degrees. 2.867 meters. In other words, we no longer have vector B. We still have A and C, so we can redraw it. We have vector A. We now have vector B in the y direction. So notice, instead of having vector B, we now have B in the y direction and B in the x direction. We still have A and C. So this is very different. Why can we now solve this problem? What's different now, Spencer? The whole goal here is to create a right triangle. Because we have a right triangle, we can use the Pythagorean Theorem and we can use a squared plus b squared equals c squared. Now, c is our resultant vector. A is this side of the triangle, A plus BY. B is this side of the triangle, B in the x direction plus C. In other words, the resultant vector is equal to the square root of the quantity A plus BY squared plus BX plus C squared. So the resultant vector is A, which was 8, plus B in the y direction, which was 2.867 squared, plus B in the x direction, which was 2.0075, plus the C, which was 5, that quantity squared, the square root of. So what is our resultant vector? I got 2 minutes, people. What's our resultant vector? 930. In other words, our resultant vector is 13 meters. Our resultant displacement is 13 meters. Come on, people, I've already said this once.
Direction.
We need to include the direction. So we come back to here, we need to figure out this theta. So we can use, let's see, tangent. We'll use tangent. Tangent theta equals opposite over adjacent. Opposite is B in the x direction plus C. Adjacent is A plus B in the y direction. Theta then is going to be equal to the inverse tangent of B in the x direction plus C divided by A plus B in the y direction. Or the inverse tangent of B in the x direction, which was 2.0075 plus C, which was 5, divided by A, which is 8, plus B in the y direction, 2.867. Angle. Please. Get an angle. It is 32.8 degrees. In other words, 13 meters at an angle of 33 degrees east of north. So notice, tip to tail vector addition. Please stop packing up. I've got like 30 seconds. All it is components of vectors creating triangles and the Pythagorean Theorem and so on, right? It's all just using that and figuring out and drawing a good picture so you can understand what's going on in the problem. I also want to talk about another problem we did in class. It was not last time, but the time before. It was the rodeo clown problem. So I'd like you to turn in your notes to page 97, practice problem number 3. I'm doing that from memory, so I'm not sure that's exactly right. So somebody check for me. 97, practice problem number 3, rodeo clown, some vectors A, B, and C. Okay. So in this problem, we had vectors A, B, and C. We figured out the resultant vector. We knew A, B, and C. We were looking for the resultant vector. If you recall, this is a vector diagram. Remember this, what is it?
Trapezoid.
Not a vector diagram. Very different. So, in this, we broke B into its components, right? We had B, it was at an angle, theta. We figured out B in the y direction. We figured out B in the x direction. And we redrew the vector diagram. A, B, Y, B, X, BX, and C to figure out the resultant vector. Right? We did this to create a right triangle. One way to approach this problem, now the reason I'm going to show you this way is not because it makes this particular problem easier, but because this is an easier problem and it's going to make more complicated problems easier. So we can list the vectors in the x and the y direction. Vector A, vector B, vector C. So, looking back in your notes, I need to know what are the components of these various vectors in the x and y direction. All of these, I believe, were in meters. So looking back in your notes for me, Christine, tell me, what are the components of vector A in the x and y directions? I actually started with that, if you'd like to pull out your notes. Isn't that where I started?
What is the one?
We'll get there in just a second. Vector A. Christine, I'm looking for the x component. We'll just start there. The x component of vector A. Vector A, you are correct, is equal to 8.0 meters north. But that is not the x component of vector A. The x component, Alejandro, of vector A is 0. What is the y component of vector A? Trevor?
8.0.
8. We'll just put 8 for now, sig fixes. Do a little bit. Great. Vector components of C. If you recall, C was equal to 5.0 meters east. What is the x component of vector C? Trevor again.
5.
5. And the y component?
0.
0. Okay. We broke B into its components. So now I need the components of vector B, please. David.
X is 2.0075.
And y?
2.867.
2.867, both of those in meters. Notice that's B in the y direction and B in the x direction. So what you can do is you can look at this in terms of the resultant vector. What is the component of the resultant vector then? Trevor.
7.0075.
7.0075. I'm going to write it here, 2 plus 2.0075. That's equal to 7.0075. And the components of the resultant vector in the y direction. What is that, Tish?
10.867.
I'll just write it out specifically, but 8 plus 2.867 is 10.867. In other words, a resultant vector has a resultant vector in the y direction and a resultant vector in the x direction, and we can figure out the resultant vector there. Right? And that is the way you should solve these problems. Because you can list everything you know, and you can just add in the x direction. You can add all the x's, all the y's together. Don't miss the fact all of these were positive. If one of them had been west, that would be not positive, but negative.